All right, guys, good afternoon. So, we are just going to be doing 3 questions to finish off this revision program. Well, this part of the revision program, we'll do some more revision work um, after the Christmas break. All right, and I don't mean January, I mean after Christmas. So, Sunday and Monday, we expect to have class again. I'm going to send some work for us to keep practicing. We have to have continuous revision in this program. All right, to keep you sharp and abreast of what we're doing. A lot of persons missing, so cannot do anything about who is not here. Can only work with who is here. All right, so I have those 3 questions to do today, so that's another reason they should come, because it's a very short session, where we're just gonna revise a couple of other things. So first question here is a linear programming question. I know all these questions are from past papers. This one says a farmer supplies his neighbors with X pumpkins and Y melons daily. So X is the number of pumpkins, Y is the number of melons. You don't know X and you don't know Y. You have to always remember that. We don't know X and we don't know Y. Alright? So X pumpkins and Y melons. Alright, the spell melons with one L this time, but neither here nor there. So they give us some conditions here, right? First condition is that Y is greater than or equal to 3. Remember that Y is the number of melons. So if we're to read this and put that in your own words, it would mean that the number of melons must be greater than or equal to 3, meaning you must have at least 3 melons. That's what this means. Then the second condition is Y less than or equal to X. Here again, we have the number of melons must be less than or equal to the number of pumpkins. And then this one, I put this one for us in words. And it says the total number of melons and pumpkins, that means X plus Y, must not exceed 12. It can be 12 or less, meaning less than or equal to 12. Alright, so as you read these things, you should know what is happening. And we don't know what they're going to ask us to do. Well, let's see what they ask us to do. This one says we have to write an inequality for the third condition. Inequality for the third condition is, as I just showed, the total number of pumpkins and melons, which is X plus Y, must not exceed 12, meaning it can be 12 or less. So it will be less than or equal to 12. So that is your third condition. And then now we're going straight into a graph. Right? I'm just going to sketch it. But let me write them out over here. Y greater than or equal to 3, Y less than or equal to X, and X plus Y less than or equal to 12. So in terms of the graph, let's just remind ourselves of how we know what to put on the graph. This one means we're going above a line. Whatever is positive is greater than means above. So going above, and the line is a part of the inequality because the equal is there. So we're going to be drawing a solid line to show that, a solid line, an unbroken line. And the line we're drawing is Y equals 3. The line associated with this inequality is Y equals 3. And that's just a horizontal line passing through 3. Y equals 3 is horizontal like that. Then this one now is, again, the Y over here on the left side is positive. So this less than means below. We're going below this line. The equals are part of inequalities. So we have to draw the line solid to show that the line is a part of the inequality or the required region. So we draw a solid line again. And the line we're drawing is Y equals X. The line associated with this is Y equals X. Y equals X is an easy line. Passes through points with X and Y are the same. So for example, it passes through 0, 0. And it passes through, for example, 6, 6. Alright? And 3, 3, and 1, 1, and so on. Then this one now, the last one, Y on the left side of the inequality is positive. So this less than means below. So again, we're going below this line. The line we're drawing is going to be solid because the equal is a part of the inequality. Then we're drawing a solid line again, solid, and the line drawn is one associated with y equals 3, y equals x plus y equals 12. And we're going to need the region bounded by the three lines, right? Let's do a sketch down here. Instead of draw and graph, we're going to do a sketch right here. Right here, we're doing it. I'm going to go 2, 4, 6, 8, 10, 12, 2, 4, 6, 8, 10, 12, 2, 4, 6, 8, 10, 12. That's the y-axis. 2, 4, 6, 8, 10, 12. That's your x-axis. All right, and 1 centimeter to 1. So you can put in like a 1 centimeter lines here in between these even numbers. Putting in the 1 centimeter marks. All right, we're ready to draw now. So the first one is y equals 3. Y equals 3. Y equals 3 is a horizontal line passing through 3. Oh, not horizontal. But the x-axis is y equals 0. So y equals 3 will be horizontal at the x-axis. Alright? So y equals 3 is a horizontal line passing through 3. So 3 right here. This is 3. Let's put it on. This is 3. Holding a horizontal line passing through 3. Then you label the line with the equal sign. That line is y equals 3. And we want above that line. Above that line. So I'm going to put the arrow pointing up to remind me that I want above this line. So the region that I want is somewhere up here. Above that line. The next line is y equals x. This one, y equals x, passing through points where the x and the y value is the same. So it passes through 0, 0. Gonna pass through 3, 3 right here, 3, 3 right here. Right here is 3, 3. 3, 3. 4, 4 and so on. But with these 2 points, we cannot draw the line. And so the line is going to be like that. Then you label the line with the equal sign. It is y equals x. And for this one, we want below. So we're going to put the arrow pointing down. So the region that you want right now is in the inside here so far. We have a third inequality to put in, which is x plus y equals 12. No, that's an easy line to draw. This one right here. It crosses the x-axis and the y-axis at the same place, 12. So it passes through 0, 12 on the y-axis and it passes through 12, 0 on the x-axis. You see? These add up to 12, see? And these add up to 12 as well, right? So that is it, an easy line to draw. Cross the y-axis at 12 up here and also cross the x-axis at 12 down here. And we'll cross this line at 6, 6. 6, 6, 6, 6. Let's see. I put this 3 the wrong place, and it's not 3, this is 5. This horizontal line is wrong. Somebody couldn't tell me. That's 5, guys. This line is wrong. That line is wrong. It's 3. 3 right here. Alright, so this is the line y equals 3. So I almost gave it away. You have to be able to spot your mistakes. That part of maths. Being able to spot your mistakes as you go. If something come up that don't make any sense, that's y equals 3. Between the 2 and the 4 is 3. Then y equals pass through 3, 3. So 3, 3 now be right here. Right here is 3, 3. Alright, so you can draw the line through that. That's better. That's the line y equals x. And again, we want to go below this line. Again, now passing through 12, 12, going back to the other line, 12, 12, and I must pass through 6, 6. 6, 6, see? 6, 6, right there. 6, 6. So it passes through here as well. So that line goes like that. Alright, that is the line. And this point has to be 9, 3. The y value there is 3. Y value is 3. The number that adds to 3 to make 12 is 9. So this point is 9, 3 right here. It's 9, 3. Alright. So question says we have to draw the lines associated with the three inequalities over here. Then after we do that, we have to shade the region that satisfies the tree inequality. Let's shade it in red. So the region satisfying the tree inequality is this one. And because then, we need to label this line with the equal sign. Let's do it. X plus y equals 12. I want below this line. See, below that line. So that red region is the region that we want. All right. This question is quite simple. They don't want any profit or anything like this. It just says determine from your graph the minimum number of x and y which satisfy the conditions. And the minimum number is at a vertex, just the same. And if I were to put it on in blue or black, this vertex right here is at the minimum number of x and y value that satisfy the condition. That's a 0.33 right there. All right, so the minimum x and y is at the 0.33. Right, so it's x equals 3, y equals 3. That's the lowest number of x and the lowest number of y that satisfy the condition. So the minimum number of pumpkins that you can have is 3, and the minimum number of melons that you can have is also 3. And basically that is it. Question done. This one didn't ask for any profit. Nice and easy. Very good?
Yes, sir.
Okay with that? Alright. Nice and easy question. And these are more recent exam. The ones from the past, the long time ones, then they tend to be the more lengthy ones where they're asking for profit and all these whole things. Even though recently they set one that was quite lengthy as well. So I guess they can bring the short ones or they can bring the lengthy ones still. Alright, so that's why we basically get comfortable with the topic. I don't know what they're gonna set. Alright, so moving on to the next question. We're only doing 3 questions today now, guys. Only doing 3 questions. So the next one is this matrices transformation. Alright, part is matrices, part is transformation. Now part A up here is matrices. It says matrix M is given as this. They should show that M is singular. Remember, if it is singular, it has no inverse, the determinant equals 0. Alright, so to show that it is singular, we need to show that the determinant is 0. So M is singular, that's what I want to show. Which means, 1, it has no inverse. Has no inverse. And 2, the determinant of M is equal to 0. When the determinant of M is equal to 0, it means that AD is equal to BC. Meaning this first diagonal product, which is AD, is equal to this second diagonal product. Because if the determinant is 0, then the 2 diagonal products must be equal. And we can use this to solve the equation, to solve it. Alright, to prove it. Or we can show that the determinant is 0. And maybe that's what we need to do. Either we show this, that the 2 products equal, or we can show that the determinant is 0. Either way. Alright, let's say we're using this one. The determinant is 0. We're going to calculate the determinant and show that it is 0. So the determinant of M would be this first diagonal product. It's negative 6 times 10. Negative 6 times 10 minus this second diagonal product. This second diagonal product, which is 5 times negative 12. Now this is negative 60 minus this is also negative 60. So negative 60 minus negative 60 gives you 0. Or you could say this minus becomes a plus. And you get negative 60 plus 60. Same as 60 minus 60, which is equal to 0. Because the determinant is 0, means that M is singular. Therefore, M is singular. That's how you prove that a matrix is singular, by showing that the determinant is 0. And I could have given a question where they say, show that it is non-singular, you know. If they say show that the matrix is non-singular, you still have to calculate the determinant. But in that case, the determinant would not be 0. It should be any other value, but not 0 if it is single, if it is non-singular. So a non-singular matrix is one where the determinant is not 0. It can be any other value, big or small, positive or negative. Right? The determinant is not 0, it is non-singular. Alright, but go to that part. Moving on to the next part, part B. Well, go to that.
Yes, sir.
Alright, let's go. This one wants us to find the value of A and B that satisfy this. So let's set it up. It's an equality of matrices. So it's 2, 1, A4 times, let's try this for better. 5B equals 8, 7. Alright, so that equality of matrices. Right? That's what we're going to solve. So what it is that this 8 right here is equal to this row times this column. That's what it is, you know. And that's how we're going to find the B. And then we're going to say this 7 is equal to this row times this column. Alright, that is it. So firstly, we can write it out like this. 2, 1 times 5B is equal to 8. So this is 2, 1 times 5B is equal to 8. And how do we multiply 2, 1 by 5, 8? We multiply along the row down the column, or we say first element times first element, second element times second element. So first element times first element is 2 times 5 is 10, plus second element times second element is 1 times B is B. And that's all equal to 8. If we take this 10 and transpose it to make B the subject, B becomes 8 minus 10, which 10 is negative 2. So know that this value right here is negative 2. And let's directly put it beside it. This now is negative 2. That's what that is. Alright? And then now we want to find the A. So the A now is this row times the 1 column equals that 7. That's what we're going to set up. So let's set it up. So we can say A4 times the column 5B is equal to this 7 under here. That is it. Remember that this B is negative 2 now. But it will be this times this first, which is 5A, plus 4 times B, which is 4B, is equal to that 7. It's supposed to be A, Mr. Short. 5A, not 5B, 5A. Alright, and then this is negative 2, so it's 5A plus 4 times negative 2 equals 7. 4 times negative 2 is negative 8. 5A minus 8 equals 7. You take the minus 8 and bring it over here, add it. You get 5A equals 7 plus 8. 7 plus 8 is 15. And then to find this A, you're going to divide by this 5. So the A becomes 15 over 5. A equals 3. That is it. What are you good at that?
Yes, sir.
Quality of matrices. Alright, good. Then we come to part C, which looks like all of this down here. Let me see. Alright, part C is everything down here. Alright, let's look at it. Alright, it says a geometric transformation S maps this point onto this point. And S is this matrix. I want to calculate X. It's a similar thing, you know. This is it. E52 is mapped by the matrix 0x y 0 onto the point 2, negative 5. What does that mean? It means that this matrix times this point is equal to that point. Okay, apply this matrix to this point. So it's going to be 0x y 0 times this matrix. The matrix for that vector is 5, 2. And the matrix for that point is equal to this point, which is 2, negative 5. So it becomes just another equality of matrices, right? So we can literally set it up now. Right? So this row times the one column is equal to that 2. So we can set that up. So it is 0 times 5 is 0. And x times 2 is 2x. That's all equal to 2. So 2x equals 2 right now. So divide by the 2, you get x equals 1. So x is equal to 1. Alright, then come back over here. Then this row now times the one column equals this value. So you can set up a similar thing again. So it is y times 5, which is 5y, and 0 times 2, which is 0, is equal to negative 5 over here. Transpose the 5, that is really 5y equals negative 5. So divide by the 5, you get x equal negative 1. Alright, it's not x, man. Why am I working with x? It is y. Oh Lord, I'm kind of tired, you know. So bear with me, guys. It is y. We did x already. Oh, that one. This is y, not x, y. That's 5y equals negative 5. So divide by this 5, you get y equals negative 1. That is it. I'm a little bit tired. That is it though. Alright, so x equals 1, y equals negative 1. So let's put what the matrix is so we can identify it now. So the matrix S is 0. The x is 1 up here. So 1. Y down here is negative 1, negative 1, 0. You should know that that is a clockwise 90-degree rotation about the origin. That's what that is. Alright? You should know that that is a 90-degree clockwise rotation about the origin on site. This question now, part 2, says this translation maps G onto G prime. And I want us to find the coordinates of G. Easy. So we have the point G. You're going to add the translation to it to get G prime. Alright. So the coordinates of G is 7, 1. So it's 7, 1 like that. A column vector. Translation is minus 3, 4. Minus 3, 4. That's equal to the G that you're trying to find, the G prime. Alright, so this 7 minus 3 is 4, and it's 1 and 4 is 5. That equals the G prime. Therefore, the question wants coordinates. So coordinates not written like this. It is written like this. So that is the answer there. Alright, that is that. The next part now says under the same transformation, this one now, right? Under the same transformation, this is mapped onto this. Calculate the values. So we can set it up. So what it is that the point H plus the translation again is equal to H prime. So H is PQ, and the translation is still minus 3, 4, and that's equal to H prime, and H prime has these values 2, 6. We can set up like that. Right? So you can take this matrix and transpose it over here now to leave this PQ as a subject. So PQ becomes 2, 6 minus negative 3, 4. And so the PQ is equal to 2, and then minus minus a plus. 2 plus 3 is 5, and then 6 minus 4 is 2. And then based on this, you can write a value for P and write a value for Q. So the P is equal to 5. And the Q is equal to 2. That is it. Very good. Easy question. Easy. This is setting on an exam paper, you know,
Yes,
so
sir.
the guys should not have a problem. Right? They should not have a problem. Right? These things too easy. So a lot of people come and know. Should not have a problem. If you miss the start of the class, you can watch the video. Alright, this one says obtain the coordinates of the image of P under the combined transformation S followed by T. Now remember, because a translation is involved, you cannot combine these two transformations in a single step. Right? You cannot multiply them and get a single trans. You have to do them step by step. Alright? You cannot do them in a single step. So we have no shortcut. So we're doing S followed by T and we cannot do it in a single step. So we're doing S followed by T, and S followed by T, they could have instead of putting it to words, they could have instead write TS. TS means S followed by T. Right? They could have written this TS. S followed by T is TS. It's just that they cannot multiply them. S followed by T is TS, but you cannot actually multiply them to get a single matrix. Right? But you still have to carry out the transformation this way. Alright? But they could have written this TS for S followed by T. But you cannot actually multiply these now because a translation is involved. The only time you can multiply the two transformations and get a single transformation matrix is when the two matrices are 2 by 2. 2 by 2 transformations. Right? Translation is a column vector transformation. Okay, you can't do it with this one. Get a single transformation matrix. Alright? So we're gonna have to do the two steps. So starting with the point, starting the point P 10, 12, let's apply the S first. So applying the matrix S, which is 0, 1, minus 1, 0, to this point, which is 10, 12, and get what the result is. So it's going to be 0 times this value is 0, 1 times 12 is 12, so I'm going to put 12 here, and then minus 1 times 10 is minus 10, 0 times 12 is 0, so it's minus 10. So that's where we're at first. And then we're going to apply the translation next to this point. So we're going to come now, bam, and apply the translation, or the translation though again. You add the translation to this. So you're adding 12 minus 10. And you're adding the translation, which is minus 3, 4. When you do this calculation, you're going to get 12 minus 3 is 9. Minus 10 plus 4 is negative 6. That is the answer. Alright. Very good. Question done.
Yes, sir.
Alright, beautiful. Alright, the next question is this one, but we did this one in the class already. Alright, so I'm not going to do that one today. Did that one as a classwork in this topic vectors, and I also did it in one of those revision classes. If you look back in the group after the vectors classwork, you'll see it. So I'm not going to waste time and do this one. I'll just do it the other day. You can go and do it again. So I'm just going to jump down and do this one, and then that is it for until we meet again after Christmas. All right, which I want to be Sunday the latest. All right, I'm going to send work in the group. So keep checking the group. I'm going to send work in the group and also tell you when we're going to have a class. All right, so the plan is for Sunday. give you a break Saturday, but definitely Sunday we have to start back, start doing some work again. I'm gonna work again Sunday and Monday. And we'll decide if we what we'll do after that. All right, keep it going. All right, so this question gives us this diagram with 2 points P and Q, as you can see there, and it says it shows the diagram and it says write down the portion vector of P and Q. So in this question, P is a point. What is it? 3, 2. 3, 2 is this point. So it means that the vector OP will have the same values in a column vector format 3, 2. And Q is a point. Q is a point minus 1, 3 up here. Minus 1, 3. And so OQ, portion vector of Q, will have the same values, minus 1, 3. There's no calculation needed for position vectors when you know the coordinates. Alright, so that finishes part A right now. Those are your position vectors, nice and easy. This part now says a point R is 8, 9. I must express QR in the form XY. In other words, I must find the vector QR. So in part B, they're introducing another point R, which has coordinates 8, 9. And if the coordinates of R is 8, 9, then similarly, OR is the vector 8, 9. And the question wants us to find part 1, the vector QR. So QR, since we know the portion vector of the Q and the R, both of them, we can use O times the last, which is OR, minus O times the first, which is OQ. That's O times the last minus O times the first. So it becomes OR is 8, 9, minus OQ is minus 1, 3. That then reduces to this minus becomes a plus. 8 plus 1 is 9. And then 9 minus 3 here is 6. That's the vector QR. 9, 6. Alright. That's the vector QR right now. Next one says, use a vectors method to show that OP is parallel to QR. Alright. If they're parallel, then 1 is a multiple of an x. Let's do that. So let's compare them part 2. We have the vector OP, which was 3, 2. I have the vector QR, which is 9, 6 right here. Now clearly this one is 3 times that, obvious. Right? You have to multiply this one by 3 for it to be equal to that. Alright, so that is it. For them to become equal, multiply this one by 3. And so you will see that 3OP, that's what is equal to the QR vector of 9, 6 multiplied by 3. Multiply that by 3, get 9, 6. That is when they are equal. When this is 3 times. So QR is 3 times PQ. 3 times OP, sorry. So QR then is 3 times OP. So here now you have expressed one vector as a multiple of an x. And this is what means that they are parallel right here. And so therefore, QR is parallel to OP. That's it. One is a multiple of an x, means that they are parallel. And this one now said determine the magnitude of PR. Determine the magnitude of PR. So to determine the magnitude of PR, we're going to calculate it first and then calculate the modulus. Alright. We're going to calculate and do the modulus. So they have the point, we need a point PR now. So for part 3, we need the vector PR, which becomes OR minus OP. That's O times the last minus O times the first. Which becomes the OR is what? The OR has these values 8, 9 minus OP. And OP has the values 3, 2, right? OP up here is 3, 2. There, 3, 2. That works out to be 8 minus 3 is 5. 9 minus 2 is 7. That is the vector PR right now. The question asks us the modulus. So the modulus of PR, or magnitude of PR, becomes magnitude of this. Square root of 5 squared plus 7 squared. That's what I get. You can write that out. That's 25 and 49 under the square root sign. So it becomes the square root of 74 units. That's the length of it, the magnitude. Alright. That's it. Then now, this part says, S has this coordinates. QS, right? QS is a column vector in terms of A and B. So they'll give us another point S now. So this question lengthy. So I've introduced the point S to us in part C. So S is the point AB. So it means that OS, portion vector of S, has the same values, which you don't know. AB in a column vector format. AB. And part 1 wants us to write the vector QS. Now QS is OS minus OQ. O times the last minus O times the first. What is OS again? OS was hold on. OS is AB, right? Right here, AB. Right, so this is AB. AB minus OQ. And OQ is which one again? OQ is minus 1, 3. Minus 1, 3, right? Minus 1, 3. So OQ is minus 1, 3. So then this minus minus becomes a plus. You get A plus 1. And then you get B minus 3. And that's your vector QS. A plus 1, B minus 3. Then it says, given that QS is equal to OP, calculate the value of A and B right here. So QS equals OP, right? So let's go. So QS, this is a part 2 now, C, is equal to OP. So QS is this one, right? So you will have now A plus 1, P minus 3 is equal to OP. And the OP, remember, is, what is OP again? Mr. Shaw, OP. OP is 3, 2. 3, 2. 3, 2. So it means that this equals 3 and this equals 2. So we can write that A plus 1 is therefore 3. Subtract the 1, you get A equals 2. And then B minus 3 is A is 2. B minus 3 equals 2. Go to 3 and add it to get the B equals 5. That's the A and B. That part is done. It's a nice question. Kind of lengthy, a number of parts, but it's nice, easy question. This part now says use a vector method to show that it's a parallelogram. OPSQ is a parallelogram. If it's a parallelogram, you have to show that the opposite sides are equal vectors. OPSQ is a parallelogram. So where do we get S again? S was this point 25, right? That's the coordinates of S was AB, right? Right here. So S is the point 25. And so OS is 25. Alright, so if we put on the diagram here, S is 25. 2, 5 is all the way up here. 2, 5. Right there. So point S is all the way up here. That's S. So the parallelogram will be this. So it's a parallelogram even on this diagram. So now we have to show that this side and this side equal, which I have that already. I have to show now that this side and this side are equal vectors. Alright, so for part 4 or part 3 of C, to show a parallelogram, if OPSQ is a parallelogram, then we know the opposite sides are equal vectors, right? So so QS would be equal to OP, but they gave us that already. QS would be equal to OP, and QS and OP we have it already, and PS would be equal to OQ. PS would be equal to OQ. Now this one we already have. So this one is already true because they gave it to us in the question, right? Right here, see there. QS is equal to OP. They told us that. Alright, now we need to show this. So we need to find PS and make it be equal and show that it's equal to OQ. Alright, so I'm gonna say now PS that I want is OS minus OP. And the OS is this one, 25 minus the OP is, keep forgetting the OP. The OP from the beginning of the question is 32. You work this out, you're going to get 2 minus 3, negative 1, and 5 minus 2 is 3. And this vector is OQ, right? Remember? OQ right here is negative 1, 3. That's what we had. So this vector is OQ. We can say where this now is equal to the vector OQ. Therefore shown. So we have shown the opposite sides are equal vectors. So we're given this one, so you never have to show that one. The QS and the OP opposite sides. See there, the QS and the OP are equal vectors, meaning they have the same length and they are parallel. And then we have to show the other pair, that's this side and this side. We have to show that the PS vector is equal to OQ, which it showed. And that's why it's a parallelogram. And that is that. That is it, guys. So you see, you get a nice, easy, quick, short class. The last class before Christmas.
Thank you, sir.
Can't say Mr. Shah kid. Yes. Alright, guys. So have a Merry Christmas. Practice some maths on Christmas Day to get the grade 1. Using 1 or 2 questions. Might send a question or 2 for you on Christmas Day. Try to have some fun, but apart from that, you all have a Merry Christmas, alright? And I'll see you all for the new year. Alright, everybody. Bye.
All right, sir. You too.